Welcome to this lecture series on plate tectonics. In this video series, we're going to be preparing to pass a content assessment for middle school science in the Summit platform. But even if you don't use Summit, this is useful for you if you want to talk about or learn in topics such as the inner layers of the Earth, how the movement of these inner layers cause movements on the surface or the crust of the Earth, and how that crust is divided into plates that move past and against and away from each other. And as they bump and crumble, passing past each other, cause lots of features of geology that we're going to learn about. And then how, because the continents are on those plates, they shift and move away and towards each other over time in a great cycle of continental drift, and the evidence that we have to support that theory. On this first video, we're going to be focusing on the interior movements of the Earth and how it impacts the surface of the Earth. So the Earth is made up of distinct layers, such as the inner core, the outer core, the mantle, and the crust, from inside to the outside in that order. The crust is just a thin little layer on the outside of the Earth. The mantle makes up most of its volume, and then in the inside, you have the core. The reason why we have them divided into these pieces is because they have distinct composition and feature or structures. The inner core is made up mostly of iron, and it's absolutely solid because even though it's as hot as the surface of the sun almost, it's actually under so much pressure from the outer layers that it cannot melt. Meanwhile, the outer core is actually molten iron and nickel, rotating and spinning and causing the magnetic field of the Earth. We are very lucky that that's the case because that creates a magnetic field that protects us from the solar winds. Without it, our atmosphere would have been ripped off and life on Earth would have been impossible, just like it happened to Mars. So we're lucky that the Earth is still hot on the inside. In a different lecture series on Earth materials and systems, I talk about why that's the case. But either way, the outer core is molten. It is also made up of iron and nickel. The mantle makes up most of the volume of the Earth. It is made of lighter elements such as magnesium, silicon, and oxygen. That's because when the Earth first formed and it was completely molten, like a ball of magma, the heavier, denser elements sunk to the bottom, just like denser things sink down on the bottom of a glass, right? And so the mantle is going to be made of slightly lighter elements than the ones on the core. Like the mantle, like the outer core, the mantle kind of flows. It is solid, but it's actually kind of like a kind of thick liquid. It's a plastic-like texture of a very, very thick magma, but it's still fluid enough that it flows in convection cells on the inside. And we'll talk more about that in detail in a second. Finally, we have the crust, which is solid, and that's the upper part of the Earth where, life is going to show up. Now, each of these layers can be broken down into further subsections, and science do so as the layers can start becoming different if you start looking into detail. And by the way, you may be wondering how we know about the inside of the Earth since we never dug in there. We use seismic waves to actually map the inside of the Earth for the most part. But either way, these layers are the major subsections of the Earth. By the way, the crust is also made of aluminum, oxygen, and silicon. So even lighter elements are going to be near the top. So what does it mean to say that the Earth has plates? That's because the crust, the outer layer, is shattered into pieces, broken from the heat of the inside trying to escape. These pieces are still forming and melting away. Some of them are sliding underneath the others and actually melting as they go into the mantle. Others are forming from the mid-ocean ridges and still getting bigger and bigger. And others are actually crumbling as they get squeezed, as they collide with others. Others are crumbling in pieces and cracking, creating new mid-ocean ridges and new splits on the surface of the Earth, new fractures. This is a process that's been happening for millions and millions of years since the Earth first cooled down billions of years ago. So the plates are each of the separate pieces that make up the surface of the Earth. There's some big ones, there's some small ones, and that is very important for this topic because these pieces are moving. And they're moving because of the convection cells inside of the mantle of the Earth. We also talk about that in more detail in the Earth Materials and Systems tutorial series. But essentially what's happening here is that the core, being very hot, warms up the bottom of the mantle by conduction, making the mantle warm up and become less dense, that rock. And because it's kind of fluid-like, it actually flows slowly upwards over millions of years, and then it hits the surface of the crust, cools down, gets denser, and then it gets denser, sinks back down, creating a cycle called a convection cell. And there's several of these convection cells happening in the mantle. And as they do, they actually rotate underneath the crust, acting like wheels that push the crust back and forth, causing the plates to move. So it's as if the mantle convection of rising and falling magma plumes act like wheels under the crust, which is like a conveyor belt. And that way, the pieces of the crust and the features in it are all attributed to the energy that's coming from the inside of the core of the Earth, that geothermal energy, rock heat, right? That's what geothermal means. Now, there are different main zones that we have to think about when we talk about that. We have the spreading zones and the subduction zones. And you can see them in the picture here. Spreading zones are zones like this right here, where the magma is going away from each other. And then subduction zones are going to be zones where the magma is colliding against each other. The magma plumes are combining, right? So let's see that in detail. So on a spreading zone, the crust plates are going to be separating because the magma plumes are moving away from each other, up and away from each other, like this. On a subduction zone, the actual plates end up crashing against each other and sliding past each other, and one of them ends up melting as it goes into the mantle. That happens because the magma plumes are going towards each other and down into the mantle. Let's see that again in the picture right here. So you see right here, as the magma plumes move away from each other, you end up getting a zone of plates that move away from each other. And as they move towards each other, like around this area or this area, the plates end up colliding with each other because the magma plumes are going towards each other and down into the mantle. Now, that creates and melts new crust. In the new crust, it was going to be formed on those spreading zones because as the plates move away from each other, there's going to be eventually a crack between them. And then that crack, magma from the mantle can actually seep through and solidify, forming new crust, pushing the crust away from each other. Meanwhile, at subduction zones, as one plate slides against the other and bumps and crumbles and cracks, eventually sinking underneath the denser one, usually that's the oceanic crust. The reason why it's denser, it's because it's more recently made at the mid-ocean ridge, and therefore made of a mantle material, which is denser than lighter, right? Or lighter, the crust is lighter than the mantle is. So since the oceanic crust is usually younger than the continental crust, it's made of material that's most recently came from the mantle, and therefore denser material than that material of the continent. So typically the oceanic crust is going to go underneath and actually end up melting away. And in that sense, the oceanic crust gets recycled over long periods of time because it forms at the mid-ocean ridge, right, at the spreading zones. But then as the ocean spreads and then eventually collides with the other crusts, it will actually sink underneath and melt away again into the mantle. And in this rotating cycle process of mantle convection, the material of the Earth is constantly remade and regenerated over millions and millions of years. New plates are formed, new cracks are formed, old plates melt away, and continents get larger and larger as the continental crust rips pieces from the oceanic crusts and get thicker and thicker over time. So that is the first objective. And on the next one, we're going to be talking about the different types of plate interactions and how they are responsible for features that we see on the Earth. I'll see you guys then.